Hi students, how are you? I think it's fine. Myself, Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, Kolani, welcome you all in my first class of chemical bonding. Chemical bonding. So before going to discussion about the chemical bonding, first of all we have to know what is the meaning of the term bonding, or more specifically what is bond. What is bond? So bond means, how we can define the bond. Bond means it is the any kind of attraction force. Any kind of, it is the any kind of attraction force. So any kind of attraction force means, between the two atoms. If you consider the two atoms, there are two atoms in this way, A and B. So to form a compound, okay, like if there is a compound, namely AB, if it is the compound AB, then to form the compound A to B to AB, there must be some kinds of attraction force between the A and the B, isn't it? So if there is some kinds of attraction force, then only it will be possible to form the compound AB. So if A is the one atom and B is the another atom, then when from the two atom one molecule is formed, when one molecule is formed, then there must be some kinds of attraction force between the two atoms. This attraction force is called actually bond. Now the attraction force may be different kinds. Like the attraction may be in this way, that here is the one atom, here is the another atom, and there only the attraction force, no direct linkage. It may be possible there is no direct linkage between the A and B, but there is a strong attraction force between the A and B, and due to this attraction force, A and B can able to form the compound AB, and this type of attraction or bond, it is called, this kind of attraction or the bond is called actually ionic bond. So you have to keep in mind, one type of bond is called actually ionic bond. I will show you that how ionic bond is formed. But before that, you have to understand that in case of ionic bond, there is no direct linkage between the two atoms. Only there will be attraction force. Now what is the attraction force? This kind of attraction force is called, it is also, you have to keep in mind, this kind of attraction force is called actually electrostatic attraction force. Okay, this is called electrostatic attraction force. So this electrostatic attraction force is mainly responsible for the ionic bond. Now come to the another type of bond. If you think about the another type of bond, then there you can expect that if there is one atom A and another atom B, then there must be direct linkage between the A and B, and this kind of linkage is called actually, it is called the covalent bond. It is called covalent bond. So first one, there was the ionic bond, and second one, it is the covalent bond. And you have to keep in mind, regarding covalent bond, you have to keep in mind, in covalent bond there direct linkage. So in covalent bond there is a direct linkage. Another kind of bond also there. This is one kind of covalent bond, but when the bond is formed, there is a little bit different kind of principles are there. That's why there is another name. This is called the coordinate covalent bond. So another kind of bond, this is called the coordinate covalent bond. Okay, so this is the another kind of bond where you can expect that there you can expect that it is one kind. After formation of the bond, there will be no difference between the covalent bond, but when it is forming, then there is different kind of principles are involved there when the bond is formed. I will discuss what is the difference between coordinate covalent bond and the covalent bond. Now first of all, if we discuss about the ionic bond, so our first we have to know what is the ionic bond or ionic solid, or how ionic bond is formed. Then we have to consider here a common example of the NaCl. Okay, so if we consider a common example for the ionic bond, if we consider the very common example, that NaCl. So now if we think about the NaCl, then first of all you have to know what is the electronic configuration of Na. This is the 2, 8 and 1. It is the electronic configuration of the Na. And on the same way, what is the electronic configuration of the Cl? It is the 2, 8, 7. Okay, now look here. First of all, when one bond or compound is formed, do you know when one compound is formed, or what is the basic reason that why one compound is formed? The compound, each and every compound is formed due to stability. Okay, stability. So stability means each and every atom of the universe, or each and every compound, there is a tendency to be more stabilized. Okay, each and every system of the universe, there is a basic tendency to be stabilized. Okay, so if you think about in this way, if you think about stability, and stability means, you know, if you we know that there is an inert gas are more stable. Okay, inert gas, if you think about the inert gas, then inert gas the electronic configuration of the inert gas, this is the most stable configuration, isn't it? So each and every atom has a tendency to get the inert gas configuration. Now if you think about the inert gas configuration, then what happened? Like sodium, so sodium also has a tendency to get the inert gas configuration. Now to get the inert gas configuration, one electron is extra here. So if sodium release one electron, this one electron, then only it is possible that the electronic configuration will be 2, 8 and the Na will convert to the Na plus. So if Na convert to the Na plus, then only it will be possible to get the inert gas configuration. On the other hand, Cl, if you think about the Cl, then look here, in case of Cl, look here that there is one extra electron, okay, required. Okay, so one extra electron, if Cl get one extra electron here, then the electronic configuration will be 2, 8 and 8, and Cl will be converted to Cl minus. So now look here, what is the criteria, or what is the requirement? Sodium, it has the requirement that it wants to lose one electron such that it will get the inert gas configuration and it will convert to the Na plus. On the other hand, Cl, it has a tendency to convert to the Cl minus. So now there is a common factor that Na will be converted to the Na plus after losing one electron, and that electron will gain by the Cl to convert to the Cl minus. And finally what happened? It is the cation and it is the anion. So if Na plus and Cl minus, if Na plus and Cl minus will form, then there will be strong electrostatic attraction force between Na and Cl minus, and due to this electrostatic attraction force, there NaCl compound will form. And this is the ionic bond actually, and the principle of the formation of the ionic bond, isn't it? So in this way we can predict that how one ionic bond will be formed. Now if we think about the another example, it is the common example of the NaCl. Now I will show you the another example of the calcium oxide. Okay, so if you think about the calcium oxide, then first of all you have to know what is the electronic configuration of the calcium. So the electronic configuration of the calcium, if you think about the electronic configuration, it is the actually 2882. So just look here, when I am writing here the electronic configuration, you have to understand, look here, there is a 2. This is the extra two electron. If these two electron will be coming out from the calcium, it will get the inert gas configuration. On the other hand, look here, oxygen. What is the electronic configuration of the oxygen? Oxygen electronic configuration 2 and 6. Okay, so if it is 2 and 6, then there are 2 electrons are shortage. That means if there is the 2 electron plus, then it will be electronic configuration will be 2 and the 8, and then oxygen will get the inert gas configuration. So what happened? These two electrons, okay, these two electrons, if calcium here, if calcium lose the 2 electrons, calcium become calcium 2 plus, isn't it? And these 2 electrons actually will gain by the easily by the oxygen, and oxygen become O2 minus. Now calcium 2 plus has the positive charge or cation, and it is the anion, and there will be a electrostatic attraction force between the cation and anion, then calcium oxide will be formed. So in this way you can predict the ionic compound or the ionic bond. But you have to keep in mind that in each and every case the compound formation principle is that stability means it should get the inert gas configuration. So here, look here, each and every case, either here calcium or here oxygen, they are getting the inert gas configuration. That's why they are formed, or they form the such kind of ionic bond or the ionic compound. So now I will discuss that there are some factors also responsible for the formation of the ionic compound. So come to the point that what are the factors. Okay, so what are the factors affecting or the factors favoring the formation of the ionic compound? What are the factors? So first factors for ionic compound. Okay, so first factor. So what is the first factor? The first factor is that number of valence electrons. Okay, so first factor is the number of valence electrons. Number of valence electrons. So what is the meaning of number of valence electron? If you think about the number of valence electrons, then valence means actually outermost electron. Okay, so for cation, which will form the cation, for cation the number of valence electrons will be, for cations, if we think about the cation, the number of valence electrons will be it will be either 1 or 2 or 3. That means if it lose the 1 electron, it will be single positive charge. If it lose the 2 electrons, it will be double positive, and if it lose the 3 electrons, it will be the triple positive charge. So in this way, expected valence electrons will be the 1, 2 or 3. Like in the previous cases, you know that in case of sodium, there was the number of valence electron was 1. If you think about the calcium, the number of valence electron was 2. Okay, but in case of anions, if you think about the anions, then what will be the valence electrons of the anions? Preferable valence electrons of the anions. So for anions, here the valence electrons will be either 5, 6 or 7. Okay, because if there are 5 electrons, then after gaining 3 electrons, because to get the 8 electrons will be inert gas configuration, you know, inert gas configuration will be 8. Okay, I can give you one example of the inert gas configuration. Like if you think about the, show you one example. If you think about the neon, okay, so if you think about the neon, the atomic number is the 10, so electronic configuration will be 8. So this is the inert gas configuration. Look here, it is required the outermost electrons will be 8. Okay, so same case here for anions. Here there are 3 electrons are required, then it will be the number of outermost electrons will be 8. So in this way, anions will be, in this case it will be the triple negative charge. If here it is the 6, then if only 2 electrons are required, then it will get the 8 configuration and it will be double negative charge. And if it is the 7, then here only 1 electron is sufficient and it will be the only single negative charge. For example, in the previous 2 cases, if you think about the chlorine, there was the 7 electrons, and that's why after gaining 1 electrons it become Cl minus. And if you think about the another example, oxygen, there are 2 electrons are sorted required. For example, it is the 6. So after gaining 2 electrons, oxygen become O2 minus. So in this way, so first case, the number of valence electrons of the cation and anion, it should be either 1, 2, 3, or it may be 5, 6 and 7. Second factor. Okay, so if you think about the second factor, in the second factor, the most important thing is the, in the second factor, the difference in electronegativity. So the second factor is that difference in electronegativity. Okay, that means that there should be difference if one is the cation, one is the cation, another is the cation for C and anion for A. Okay, so here if we think about the cation for C and anion for A. Okay, so there must be difference, high electronegativity difference between cation and anion. Okay, high electronegativity difference is required. Okay, high electronegativity difference is required, because if you think about the ionic compound, cation, they generally electropositive. Why? Because if cation is not electropositive, for example sodium, like metals, maximum metals are electropositive, so then only if it is electropositive, then only it can easily lose the electrons. Okay, otherwise it is not possible to lose the electrons. On the other hand, anion should be electronegative. Okay, it should be electronegative, because you know anion, they gain the electrons. So for this purpose, anion should be highly electronegative. Okay, so that's why to form an ionic compound, cation should be electropositive and anion should be electronegative. Third case, or the third factors. If you think about the third factors, then in the third factor, then size of the ions. Generally, if the cations are smaller and anions are larger, it is the preferable case for the large cations and the small anions, okay, then it will be the favorable, it is the favorable for the formation of the ionic compound. Generally it happen actually, cation means after losing one electron its size become lower after losing one electron, you know, and after gaining one electron its size become high or the larger, okay. So this is the general, very general case. Then ionization enthalpy and the electron affinity, this is the another fact actually. Ionization enthalpy, that fourth case, it is the fourth factor actually. If we consider the fourth factor, then in the fourth factor, the most important thing is that ionization enthalpy and the electron affinity. So ionization enthalpy means the energy required to lose one electrons actually, and electron affinity means the amount of energy released when one electron is taken by the atom. So then what happen actually, lower the ionization enthalpy of the electropositive atom. Lower the ionization enthalpy of the electropositive atom means that if the atom A, if it easily lose one electron and it become A plus, it is the required factor for the formation of the ionic compound. So easily, then at that time easily the compound or the case of the formation of the condition will be the suitable. Another case, if you think about the electron affinity, then what happen that if the anion has the if the anion is preferable by the that its electron affinity value, that higher the negative electron gain enthalpy of the electronegative atom is the very much easier factor for the formation of the anion. That means if any of the anion, if it is the cation, if it is the cation is the C, okay, if easily it can form after gaining one electron, then what happen, the ionic compound will be formed more easily, okay. So these are the condition of the ionic compound, and then we'll move to the discussion about the covalent compound. If we think about the covalent compound, what I told you, that covalent compound generally it is formed, covalent compound generally it is formed by the overlapping of the orbitals, okay. We have to keep in mind that there must be some overlap of the orbitals. So overlap of the orbitals means, you know, I told you when I started the class that there is a direct linkage between the two atoms in the covalent bond. Now this direct linkage, how it is possible, because in case of ionic compound, you know that there is no direct linkage, so no question of the such kind of overlapping of the orbitals. But here in case of covalent compound, you know that there must be the requirement will be the direct linkage. So in case of covalent compound, there is an, like if it is the, for example, if it is the p orbital, so there must be another p orbital which should overlap with other, like if it is the A, it is the B, then only it is possible, then there will be the direct linkage between the A and the B. So in case of covalent compound, there will be the orbital overlap. Now in case of covalent compound, there orbital overlap means there must be contribution of the electrons. So here in case of covalent compound, there is the sharing of the electrons, okay. Overlap means actually it is the sharing of the electrons, okay. So there are two types of covalent compounds are also possible. One is the homoatomic, another is the heteroatomic, okay. So what is the homoatomic and what is the heteroatomic? Homoatomic means that the same kind of atoms are present, like H2. When H and H they are formed the bonds, then H2 is formed. Another example is the heteroatomic. Heteroatomic means like the different atoms are present. For example, HCl. Okay, so this is the heteroatomic H and Cl. When they form the, when they attach with each other, they form the covalent compound. Okay, so now look here. If we think about, if we think about the H2, then you know H has only one electron, but it has a tendency to get the electronic configuration of helium. I told you that nearest inert gas configuration is required for each and every atom to be stabilized. So hydrogen is required very much to get the electronic configuration like helium. So here, look here, it required one electron to get the electronic, because helium has the 2 electrons, so it required 1 electron to get the electronic configuration like helium. So one hydrogen, it has, for example, 1 electron here. Another hydrogen also such kind of electrons, 1 electron here. So then what happen, they both the atoms, they can share the electrons such that they are not losing the electrons, actually they are sharing the electrons. Sharing the electrons means both the hydrogen can use the electron. Okay, so this is actually the orbital overlap, what I told you, and that's why one hydrogen will form the bond with another hydrogen, and then each and every hydrogen, actually it has the 2 electrons, one its self electrons and another electron is coming from the another hydrogen. So both the electrons are using the electrons by sharing, and ultimately it will get the electronic configuration like helium. So in this way, actually here covalent bond is formed. On the other hand, look here, I'll give you the example of the heteroatoms. So if you think about the heteroatoms, so here, like I'll take some examples of the HCl. So simple example of the HCl. So same way, hydrogen, you know, hydrogen has the 1 electron. Okay, and Cl has the Cl liquid also 1 electron. Okay, because you know, Cl has the here it has the 7 electrons. Okay, so Cl has the 7 electrons, and hydrogen, it also has the 1 electron, and 1 electron is required. So what happened, they can share these electrons, both the electrons they can share, and finally they can form a covalent bond. This is called the HCl. Okay, so this is called the actually covalent bond. This is called the covalent bond. Okay, and the compound where covalent bond present, these compounds are called covalent compound. These compounds are called covalent compounds. Now there are some condition to form the covalent compounds. First of all, here also, that what are the condition means, first of all, you know, in case of covalent compounds, their electrode negativity difference should be very minimum. Okay, or the minimum of the electronegativity difference. So first of all, like the previous case, I'll tell you that they are valence electrons. Okay, so if you think about the valence electrons, then here that valence electron for both the cases, it may be 5, 6 or 7. Okay, formation of the covalent bond is favored by each of the contributing atoms process either 4, 5, 6 or 7 electrons. Okay, so valence of electrons, so such atoms form, most preferable is the 5, 6, 7. Okay, you have to keep in mind, if it has the 5 electrons, then here 3 electrons. Look at a simple case, if A has the 5 electrons, if A has the 5 electrons and another A has the 5 electrons, so there 3 electrons are required, isn't it? Because 5 plus 3, then only it will be 8. So here what happened, 3 electrons should be shared. 3 electron sharing means each and every case there will be one bond will form. So there are 3 bonds are formed, like in case of N2. Okay, so in case of N2, if you check the example of the N2, then you can find out that in case of N2, there are three covalent bonds are present. There three covalent bonds are present. Three covalent bonds are present. In the same way, oxygen, there two covalent bonds are present, and if you think about the fluorine, then one covalent bond is present. So in this way, so actually depending on this, either 5, 6, 7, in this way their number of bonds are formed. So the next factor is that in case of in case of here electronegativity difference, there should not be or very minimum amount of electronegativity difference. So that's why maximum p block elements, you know, like oxygen, nitrogen, fluorine, if there is the two p block element n, there no electronegativity difference, almost f, no electronegativity difference. So this kind of very nominal electronegativity difference, or there should not be an electronegativity difference, then it is preferred. Like in the previous case, there must be high amount of electronegativity difference, but here not like the case. Okay, and the high ionization enthalpy, here it is required that high ionization enthalpy. If it is high ionization enthalpy, no scope or very difficult to form cation, isn't it? Cation, because if it is very high ionization enthalpy, to form like A to A plus, it will be very much difficult to form A to A plus. So that's why no scope of formation of the ionic bond. So there is a tendency of the formation of the covalent bond like this. Okay, and then obviously there these case are very much, these conditions are very much helpful to predict either the compound will be covalent or the ionic. And there are some differences also regarding covalent compound and the ionic compounds also. Like if you think about the difference, then obviously in case of ionic compounds, if I make a difference, like here it is the ionic compound, ionic, and here it is the covalent compound, ionic and covalent. Then ionic compound, obviously here purely electrostatic attraction force, it is the electrostatic attraction force. Okay, purely it is made by electrostatic attraction force, but here it is the combined together by the formation of the covalent bond, Okay, second case, if you think about the ionic compound, then the attractive forces are actually non-directional. Okay, non-directional means if here the attraction force may be any direction. Okay, it is the non-directional, because here the attraction force may be from any direction. Okay, any direction, but it is the directional because here is a direct linkage between the two atoms. Okay. Second is the their ionic compounds are mainly, it is the solid, and here covalent compound are mainly gases and liquids. And these compounds are solid means obviously it is the hard. Okay, and its melting point and the boiling point will be more higher. Okay, where the melting point and the boiling points are comparatively lower in the case of the covalent compound. Okay, so this is all about your ionic compound, ionic bond, covalent compound, covalent bond, etc. In the next class we will discuss about the hybridization, that means sp2, sp3, how we can predict, and the what is the hydrogen bonding and related topic of the hydrogen bonding. Okay, so thanks to all of you, thanks for watching this video. Thank you. Meet with you in the next